Welcome back. We are talking about powers and roots today. First, we got to go over a couple of definitions. Might be something that you haven't seen very often, or might be something you're just looking for clarification on. It can be kind of a difficult thing to think about exponents and powers and roots. So, what an exponent is a number when written smaller and above another number that tells you how many times a number is going to be multiplied by itself. So it's one of these little numbers, it's written right above a bigger number, and it tells you how many times that bigger number is going to be multiplied by itself. When we look at exponents, we're going to look at something called an exponential number, or just a power, is sometimes called. A power has two parts to it. It's got a base, which is right here, this little 5 here, and it's got the exponent that we talked about, that little number above the 5. When we take a look at something like this, we call this a power, and we say 5 to the power of 4. So it's the base to the power of the exponent. When we look at the value of what an exponential number is, well, we're taking that 5, and it's got that little 4 up above. So we're taking 5, and we're taking 4 of those. And what we're going to do is we're going to multiply all of them together. So you'll have 5 times 5 times 5 times 5. That is 5 to the power of 4. So you're multiplying 5 4 times together. Some powers have nicknames, and that's the square and the cube. So the square means that the exponent is going to be 2. So we've got 4 to the power of 2 here, and what we say is 4 squared. Cube means that the exponent's going to be 3. So 6 to the power of 3, we just usually say 6 cubed. When we write these out, 4 squared, it's just 4 to the power of 2. So you're taking 2 4s and multiplying them together. If you take 6 cubed, you're taking 3 6s and multiplying them together. Pretty simple. Square means that you're doing it twice. Cube means that you're multiplying by itself 3 times. Now, any number can be raised to a power, whether it's whole or whether it's not. So we've already looked at 4 squared here already, and 5 cubed a little bit, not really. But when we look at 4 squared, we have 4 times 4, and that value is just going to be 16. We can also take, let's say, 4.3 squared. Then you'll take 4.3 and multiply it by itself twice, and you'll get 18.49. Same thing for cubes. If you have 5 to the power of 3 or 5 cubed, you'll have 5 times 5 times 5, which is just 125. You can also take 5.1 and cube it. So you'll have 5.1 times 5.1 times 5.1, which will be 132.651. So a square is multiplying itself twice. A cube is just multiplying by itself 3 times. Another way of looking at it is for a square, it's the area of a square when we are given a side length. So 4 squared, for instance, will have a side length of 4. Of course, it's a square, so they're both the same. And that area of that square will be 16. For a cube, it's along the same lines. The volume of a cube given a side length. So if we have 5 cubed, you have the side lengths of 5. Again, it's all the same because it's a cube. And 5 times 5 times 5, like we did above, is 125. So that's a square, and that's a cube, and those are powers. The opposite operation of a power is something called a root. And this is probably one where people get tripped up a little bit more than just powers. It's trying to think the reverse way. The opposite of a square is just a square root. And it looks like this. It's got that little symbol that looks like that, and it's got a number underneath. The opposite of a cube is a cube root, and it looks the same way. It's just that little symbol has a 3 next to it. That's called a cube root. Now, if you haven't seen these before, they kind of look all the same. They look like this. That's going to be n root x. That denotes a root. or symbolizes a root, and we usually call them radicals. Just like powers and bases and exponents, they've got little parts to this. N is called the index of the radical. The x in this case is called the radicand. You see that there? And this little guy here is just the root symbol. It's what we use to symbolize the root, that we're taking the root of a number. That index is really important because what the index does is it tells us just how many times that number or a number must be multiplied by itself in order to get to the radicand. Okay, so if we're looking for, let's say, 3 root or the cube root of 27, and we're going to look at that below. What we're doing when we take a look at the cube root of 27 is we're finding a number when cubed or when multiplied by itself 3 times that would give us 27. Okay, we can do it for any other number, right? The cube root, or if we say the 5th root of 125. We're looking for a number when you multiply it by itself 5 times, that'll give us 125. Okay, those answers can be decimal numbers. We're going to focus on just whole numbers right now because they're kind of more simple to think about, but those answers can be decimal numbers. When there is no index written, so if we have something just like the root 9, we act like that little index is 2, okay, but we don't have to write it. So that square root of 9 is just a number when multiplied by itself that gives you 9, which is going to be 3. Okay, so that's all we're looking at when we're looking at roots. If it's a square root, we're looking at a number when multiplied by itself. It gives us the number under the root symbol. And the same thing with a cube root. So we have 2 examples down here. We've got the square root of 49. So what we're thinking when we're looking at this is which number, when squared, would give you 49? Well, we have to go through our squares and square roots, or our powers and exponents, and eventually we end up with 7. That one is a little bit more difficult to figure out because 49 is a little bit of a different number. If we take a look at, let's say, the square root of 36, okay, and we take a look at 36 and we make a little factor tree, we're taking a look at 2 numbers that'll multiply by itself to give us 36. Well, I'm going to say 12 times 3 will give me 36. And I'm going to try to break them down until we're all in our prime factorization, which is this one here. When we get to the end and we get all prime numbers, we group our numbers into groups of 2. So we have 2 2s and 2 3s. And so we say that the square root of 36 is going to be 2 times 3, which is just 6. So 6, when multiplied by itself, gives you 36. And that's a way to find it out, by using something called prime factorization. Okay, we can do the same thing with cube roots. So when we look at cube roots, we think, okay, what's a number when we cube it that will give me the number underneath? So we're looking for that number 27. Okay, so when we take the cube root of 27, okay, we're going to take a look at that number underneath the root. We think, okay, what are 2 numbers that multiply together to give us 27? Well, I know 9 times 3 gives us 27. And I know I can break down 9 into 3 times 3, which means that the prime factorization of 27 will be 3 times 3 times 3, or just a bunch of prime numbers that multiply themselves to give 27. So I know that, hey, if I group this into a group of 3, I only have one group, so that answer is just going to be 3. If I take 3 times 3 times 3, that should give me 27. So using the prime factorization is a good way to do it by hand. If you are allowed to do it, I would use a calculator, but knowing how to do it by hand does come in handy. Square roots. So if we took a look at square roots, and we think about them in the same kind of like geometric way or in the way of shapes, the square root of a number is just the side length of a square when we're given the area. So in this square, we're given that the area is 49, so we know that the side length is 7 because the square root of 49 is 7. When we're looking at a cube root, we're looking for the side length of a cube when we're given its volume. So if we're given that the volume is 27, well, we know that that missing area or that missing side length is just 3, because 3 times 3 times 3 gives us 27. You can look at the cube roots of these two numbers as well and find their prime factorization and find their cube root by using prime factorization. If I take a look at 64, I can break it down into, okay, well, I've got 2 times 32. Okay, and I'm going to take a look and see, well, I've got 2 times 16 here. And then I carry that down with me. Don't want to forget one of my factors. And if I keep breaking this down, I'll end up with, this will be 8 times 2. 2 times 8 times 2 times 2. Because we bring our 2's down with us. We're going to bring our 2's down with us again, and we're going to split this up into 4 times 2 times 2 times 2 times 2. And last but not least, we're going to get 2 times 2 times 2 times 2 times 2 times 2 when we break it all down. Now remember, we're cube rooting it. So that tells us we're going to find groups of 3. So we have 2 times 2 times 2, 2 times 2 times 2. We've got 2 groups of 2. And so when we take a look at this, we're going to have 2 times 2 be our cube root of 64. And that'll leave us with 4. So when we take 4 and multiply it by itself 3 times, the answer is 64. 4 times 4 times 4 is 64. So you can see that these two things, of course, are very closely related. If you want a chance to practice, try this cube root of 216. We have said that number, the answer, in this video, of course. Not that that is much of a hint. Now, we've gone over the powers and we've gone over the roots. They're opposites of each other. They're very closely related, and they do take some practice, especially with the roots, in order to fully understand them. So make sure you're practicing a bit. Try to find the cube roots of some numbers and the square roots of some numbers using that prime factorization. You can start out by using these numbers here. But if you liked what you've watched and liked what you listened to, make sure to hit that subscribe button, drop me a like, give me a comment, tell me what you think about the video, and if nothing else, have a great day. Thank you.